triple integrals. Or definition of a double integral of a real valued function fx, y over a region D in R square can be extended to define a triple integral of a real valued function f, x, y, z over a closed region B in R cubed. The triple integral of fxyz over the three-dimensional region B is denoted by triple integral on B f x y z dv, where the symbol dv is often called the differential element of volume. Similar to a double integral, a triple integral can be converted to a triple iterated integral, which can then be evaluated by means of ordinary single variable iteration. Now, we calculate the triple integral. B is a region which is bounded below by a surface z equal to z1 xy and bounded above by a surface z is equal to z2 xy. We draw this area x, y, and z. This is a surface. Z is z2. And this surface is z1 xy. This is B. Volume in R cube. And this is D. D is the projection of B onto the xy plane. D is projection of B onto the xy plane. Then, if you want calculate triple integrals on B f x y z dv is equal to double integral on D. D is the projection of B onto the xy plane, and Z1 bounded below and Z2 bounded above f x y z dz and dA. Firstly, we calculate this integral and then we calculate this double integral, where B is x, y, z, so x, y on D and Z1 is equal smaller than Z is equal smaller than Z2. And D is the projection, this area, D is the projection of B onto x, y plane. Note that, please note that the first integration will result in a function of x, y, x and y. The resulting double integral over the region D is then evaluated by using the theorem. For example, if D is y simple, then do you remember the theorem? D is x, y, so A is equal smaller than x is equal smaller than B, G1x is equal smaller than y is equal smaller than G2x. This is y simple region. We can express the triple integral over B as an iterated integral of this form. Triple integral on B f x y z dv is equal to from A to B and from G1x to G12 and from Z1 and to Z2 f x y z dz dy and dx. The iterated triple integral given above is a sequence of integrations. Now, change of variables in triple integral. Change of variables. A change of variables has been proved to be quite useful in simplifying the technicalities involved in evaluating double integrals. The concept of changing variables can be extended to triple integrals. There is a smaller change of variables formula for triple integrals. Let T be a transform from the U, V, W space to the X, Y, Z space. X is X, U, V, W, Y is Y, U, V, W, and Z is Z, U, V, W. And suppose that T maps a region nu B in U, V, V, W space onto a region. And the Jacobian of T transform is Jacobian partial derivative symbol x, y, z, old coordinates, and partial derivative symbol new coordinates u, v, w. This is symbol of Jacobian is determinant. Firstly, x, 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 and y, 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 and z, 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 and u, v, w, u, v, w, u, v, w. You can calculate this determinant easily. Under hypothesis similar to double integral, we have the following formula. Formula is triple integral on B f x y z dv is equal to triple integral on new B, new area, f x u v w y u v w z u v w. Don't forget the Jacobian, absolute value of Jacobian, and new dv. This is formula. Similar to double integration. And example. We think about cylindrical coordinates. X, Y, and Z. Cylindrical coordinates are really nothing more than an extension of polar coordinates into 3 dimensions. This is phi, rho, and z. This is P point, rho, phi, and z. The transformation is defined by the equations x is equal to rho cos phi. This is x rho cos phi. And y is rho sin phi. And z is equal to z. It is same. Where rho, phi and z are cylindrical coordinates. The Jacobian of transformation, Jacobian of this transformation J is x, y, z and rho, phi, z. This is determinant of x, y, z, and rho, phi, z, rho, phi, z, rho, phi, z. So, Jacobian is determinant of x is derivative for rho cos phi, derivative for phi minus rho sin phi, and derivative for z, it is 0, and sin phi, rho cos phi, and 0, 0, 0, and 1. Plus, minus, plus, minus, plus, 1, product, rho cos square phi, minus is plus, rho sin square phi, this is rho. Jacobian of cylindrical coordinates, the Jacobian of transforms is rho. And triple integrals in cylindrical coordinates take the following form. Triple integral on B f x y z dv is equal to triple integral on nu b and f rho cos phi, rho sin phi, and z. Don't forget the Jacobian. This is rho and nu dv, and is equal to and calculate now. And now we think the spherical coordinates. This is x, y, z. Phi and theta and r. This is P point, r, theta, and phi. To convert from spherical to rectangular coordinates, we use the these equations. X is, please attention, this is r. So this is r sin theta. This is r sin theta. And now x is r sin theta product cosinus phi. And y is again r sin theta product sinus phi. Z is this r cos theta, where r theta, and phi are spherical coordinates. R is from 0 to infinity. Phi is from 0 and 2p, coincides with the polar angle. The azimuthal angle is theta, must be the interval. Theta is 0 from 0 to p. This is important. Theta is the angle between the positive z-axis and the line of segment OP. If theta is equal to 0, OP is the negative, OP is coincides with the positive z-axis. If theta is 0, the line segment OP is coincidence with the positive z-axis. If theta is equal to p, 180 degrees, OP is the negative z-axis. Any line segments with theta is p divided 2 lies in xy plane. This is important. Jacobian is symbol of Jacobian. You can calculate easily x, y, z, r, theta, phi, phi. Calculate easily. Solution is r squared sin theta. Using the equations related to change of variables in triple integrals we obtain triple integrals on B f x y z dv is equal to triple integral on new B f r theta phi r square sin theta dv. This is Jacobian. Now, we can make an example. This is simple concept questions. Evaluate triple integral on B 2x dv, where B is the region under the plane 2x plus 3y plus z is equal to 6 lies in the first octant. The word first octant is related to things of coordinates, namely x is bigger than 0, y is bigger than 0, and z is bigger than 0. Now we draw the region. This is x, y, and z. If we say y and x is 0, that is 6. We say y and z is 0, x is 3. And x and z is 0, y is 2. So this array, and we say lies in the first octant. This is first, this array. Now, if you want this triple integral on B 2x dv, we use the Cartesian coordinates. Now this is z, and this is lower boundaries. Z is 0 and upper boundaries is z is 6 minus 2x minus 3y. So double integral on D is projection of B on xy. So this area. this area is D, projection of B. This is D area. And Z is Z from 0 to Z is 6 minus 2x minus 3y, and 2x dz dA. This integration you can do easily. Two x z 0 6 minus 2x 3y. So double integral on D 2x 6 minus 2x minus 3y minus 0 is equal dA is equal to double integral on D 12x minus 4x squared minus 6xy dA. D is projection of B onto the xy plane. So x, y, this is 3 and 2. This is D area. D is xy, so from 0 to 3, and y is from 0 and 6 minus 2x divided 3. Why? Because this line is y is 2 minus x divided 3. Because two and 3 you can calculate easily. Y is minus 2, this is tangent, x, and plus 2, this is. And if you directly write on this equation z is equal to 0, you can easily find y is these equations. Same. Okay? And we have expressed D as y simple region. This is double integral, you know. And then now double integral goes to x is from 0 to 3. From 0 to 3. And y is from 0 to 6 minus 2x divided 3. And 12x minus 4x squared minus 6xy dy dx. Calculate easily, and then from 0 to 3. 4 divided 3 x cubed minus 8x squared plus 12x dx. This is polynomial integration. So easy, and calculate. This is 9. Sorry. B is the region bounded by the four planes. X is 0, y is 0, z is 0, and 2x plus 3y plus z is equal to 6. This is solution.